Good morning, everyone. So today we'll be looking at we'll be talking about physics, and as you can see on the board, and one of the basic courses or subjects you need as a science student is this course called physics. Very, very important. And you know that physics is the pure science that deals with the behavior of matter and energy and how it relates with other physical properties. So there are two things you study when dealing with physics. Number one is matter, and number two is energy. And you know that matter is anything that has mass and can occupy space, and energy is the ability to do work. So you are studying that thing that has mass and occupy space and also have the ability to do what? To do work. So that is what physics talks about, talking about how matter performs work, or how matter do work. Is that not so? So we have two branches of physics. Number one is the classical physics, and number two is the modern physics. So when you go that way, you study them, you understand their differences. There's a difference between classical physics and there's a difference between modern physics. So I don't want us to go deeper in that side. So today we'll be looking at two things in physics. Number one is called distance, and number two is called displacement. So give me 10 minutes of your time as I explain these two terms for these two quantities for you. We have what we call distance. We have what we call distance, and we have what we call displacement. They are almost similar, but there is a difference between the both of them. So before you understand distance and displacement, I will introduce you to something we call the scalar quantities and the vector quantities. I believe you were taught this in secondary school, scalar and what? And vector. And what are scalar quantities? Scalar quantities are quantities that have magnitude and numerical value but have no direction. Scalar quantities are quantities that have what? Magnitude, they have numerical value but they don't have direction. For example, we have mass. Mass is a scalar quantity. We have distance. Distance is a scalar quantity. We have temperature. Temperature is a scalar quantity. Are you following? We have time. Time is a scalar quantity. We have what? We have speed as a what? As a scalar quantities. They all have magnitude. They all have numerical value, but they don't have what? A specified direction. Then when we come to vector quantities, we're talking about those quantities that have both numerical value, they have magnitude, and they also have directions. They have magnitude, they have numerical value, and they also have what? Directions. For example, we have weight. Weight is a vector quantity. We have displacement. Displacement is a vector quantity because it has a direction. We have temperature. We have velocity as a vector quantity. We have force as a what? As a scalar vector quantity. So we have so many types of vector quantities, and we have more types of scalar quantities. And you must know which quantities in physics are scalar, and you must know which quantities in physics are what? Are vectors. They are very, very important that you get this knowledge. So moving forward, you can see that there we have distance as a scalar quantity and we have displacement as a what? As a vector quantity. That is number one difference between this distance and what? And displacement. Now, what is distance? Distance is a measure of the separation between 2 points. Distance is a measure of the separation between 2 points. It has magnitude but no fixed direction. Hence, it is a scalar quantity. So when you talk about distance talks about what? The differences between what? Or a measure between the separation of 2 points. For example, you have point A and you have point B. The difference between point A and point B gives you what we call distance, which is noted as what? As S. So the difference between point A and point B is what? Is called distance, the separation between 2 points. And In distance, you must understand two things. Number one thing you must understand is distance in a plane. The distance in a what? On a plane. And also you must understand the distance in what? In space. These are the two things you must understand in distance. Number one is distance on a plane. This is where you are given only 2 points, your point A and your point B. When you are given this, it's just like your graph, your quadratic graph, where you have your positive side, you have your negative side, your positive side, your negative side. So this is distance in a plane. This is how it looks like. And this is distance when you have three directions given, or you have three points given. You have, let's imagine this is X, and this is Y, and this is Z. Do you understand? So we have, and this will give you your X1, this will give you your X2, this will give you your Z2, this will give you your Z1, this will give you your Y2, this will give you your Y1. But this is A1, this is B1, this is A2, this is what? B2. So this is distance in a plane, and this is distance in what? In space. There is a difference between the distance in a plane and a distance in space. And I'm going to, because this is where most students find it very, very difficult to understand the differences between distance in a plane, because you can be given a calculations and they will say calculate the distance in space and or calculate the distance in what? In a plane. So we are going to be seeing the formula between the formula in the distance in a plane and the formula distance in a what? In space rather. So let's look at that. But before then, what is a plane? A plane is a geometric figure defined by two reference frames. A plane is a what? Is a geometric figure defined by what? Two reference space, while a space by two reference frames rather, or two-dimensional coordinate system. So in a plane we only have two coordinate systems, while what is space? A space is defined by three reference frames. So there is a difference between a plane and a what? And a space. A plane is given by what? Two reference frames or two-dimensional coordinate system, while your space is given by what? Three reference frames or three-dimensional coordinate system. And I believe they taught you your coordinate system in your secondary school, so you need to go and do your research on that and understand it perfectly. So let's look at the distance in plane. The distance in a plane, the formula is given as S is equal to the square root of what? Imagine you have for that of a space, it will be given as X and what? And Y. You understand? Or you because you remember it is two coordinate system, so you have your X1, your Y1, your X2, your Y2. This is distance in a plane, and the formula is what? X2 is X2 minus your X1 squared plus your Y2 minus Y1 squared. This is the formula for calculating distance in a plane. While that in space is calculated as X1, Y1, Z1. This is how your question always look like. Then you have your X2, Y2, Z2. So the formula for that in space is the square root of X2 minus X1 squared plus Y2 minus Y1 squared plus Z2 minus Z1 squared. So when you use this formula to solve, when you understand this formula, you can solve any equation in distance. This is the general formula. They can either give you in space or they can give you in what? In a plane. So when they give you in a plane, they ask you a question. For example, I want you to solve this at a convenient time. I want you to solve this. They say calculate the distance between the point A and point B, and point A was given as 2 and 3, and point B was given as minus 5 and 1. So this is your X1, this is your Y1, this is your X2, this is your Y2. So when you use this formula, when you substitute this value this formula by these values here, you will get your answer. For example, I will just solve it directly for you to understand. You will have, where is your x2? This is your x2, so you are going to be having -1. Where is your x1? This is your x1. You say -5 -2, which will give us what? -7 squared. Plus, you will now say, where is your y2? Your y2 is 1 minus, where is your y1? Your y1 is 3. So 1 minus 2 will give us 1 minus 3 will give us what? -2. So you are having -7 squared plus -2 squared. So when you do that, you are going to be having -7 squared to be 49 plus -2 squared to be what? To be 4. So when you say 49 plus 4 will give us what? 53. Is that clear? 53. So you now see the square root. Remember, you have not solved your square root. So you now see the square root of what? Of 53 will be what? Will be 7.3 units. So that is the answer. Very, very simple. That is when you are given in a plane. Then when you are given in space, you use the same formula, but you are adding 3 reference points. So they must always give you a question having 3 reference points. Is that clear? So we are going to see, and lastly, let me just paraphrase displacement. Displacement is the distance covered in a specified direction. So displacement and distance, they are very, very they are almost alike, but the difference is that displacement deals with what? A specified direction, while distance does not deal with a what? Does not have a specified what? Direction. So it's very, very simple to understand these things, and I trust that God will continue to grant you the understanding to get more on them. So if you are given a question in displacement, you are always given a direction. You are always given a what? A specified direction. It's as easy as that. And it's the same formula you use to calculate that of distance and displacement. It's the same formula you use, but the difference is that one is giving direction, the other is not giving direction, and the other one you have to plot a graph. Because of our time, you might not have time to do all those things. It's very, very simple. So that is what distance is, and that is what displacement is. So in our next class, we are going to begin from motion. So when we talk about motion, we'll just do a little recap on what we learned from our secondary school. Thank you very much for watching. See you in the next class.